George Boole was an English mathematician in the mid-1800s who taught at Queen's College in Ireland. And he's well known for his work in differential equations, but probably best known for his work in algebraic logic, and particularly the idea of Boolean expressions and Boolean values, which is the basis for how our computers work. So without George Boole, we may not have computers. A Boolean expression is one that evaluates to true or false. There's only two values it can have. And a Boolean expression, to be evaluated, contains a Boolean operator. So here's some expressions that are true. 1 plus 1 is equal to 2. So those double equals is the C# Boolean operator for is equal to. Then we have less than. 1 plus 1 is less than 1 plus 2. Both of those, of course, are true statements. We know that 1 plus 1 is 2, and 1 plus 1, or 2, is less than 3. The next operator is the greater than symbol. 6 plus 3, or 9, is greater than 4 times 2, which is 8. 9 is greater than 8. That's a true expression. The fourth operator there that you see in the yellow is less than or equal to. So 1 plus 4 is 5. Is less than or equal to 3 plus 2, which is 5. 5 is not less than, but it is equal to, and it can be either one of those. In the same vein, we have a greater than or equal to. In this case, 1 plus 4 or 5 is greater than or equal to 3 plus 2, which is 5. 5 is equal to 5. It's not greater than, but it's equal to. Notice that this is an or, so it's one or the other. And then the exclamation mark is the not operator in C#. And so 1 plus 1 is not equal to 1 plus 2. 2 is not equal to 3, and that is a true statement. So all 6 of those expressions evaluate to true. Here are some similar expressions that evaluate to false. 1 plus 1 is equal to 3. Of course, that's a false statement. 1 plus 3 or 4 is less than 1 plus 2 or 3. 4 is not less than 3. That's a false statement. 6 plus 3, or 9, is greater than 4 times 3, which is 12. 9 is not greater than 12. 1 plus 4, or 5, is less than or equal to 3 plus 1, or 4. 5 is not less than 4, and is not equal to 4. The next expression, we have 5. 1 plus 4 is greater than or equal to 6. 3 plus 3. That's a false statement. And then finally, 1 plus 1 does not equal 2. That, of course, is a false statement. Most often when we're working with Boolean expressions, those expressions are going to involve variable values, and those values will change over the course of the running of the program. So sometimes they evaluate to true and sometimes they evaluate to false. So let's say at this instance of time, A is equal to 2, B is equal to 4, and C is equal to 8. And so we see some expressions here such as A times B is equal to C. 2 times 4 is equal to 8. A plus B, 2 plus 4 is 6, is less than 8 times 2, which is 16. 6 is less than 16. C times 3, 8 times 3 is 24, is greater than the math.pow expression of 4 comma 2, or 4 squared, which would be 16. So 24 is greater than 16. A times 2. 2 times 2 is 4. It's less than or equal to C, which is 8. 4 is less than 8. And then B times 2. 4 times 2 is 8, is greater than or equal to C. In this case, it's equal, so that's a true expression. And then A times B, 2 times 4 is 8, does not equal 8 divided by 2, which would be 4. And of course, 8 does not equal 4. Those expressions may come up again later in our program, and if those values for A, B, or C have changed, whether they evaluate to true or false may also have changed. Sometimes the expressions involve properties, or they involve methods that return a value. So if xyz is a string containing the word south, then xyz.length is equal to 5 is a true statement. There are 5 letters in that expression contained in xyz. xyz.index of uppercase S, of course, would be 0, and 0 is less than 2. That is a true statement as well. So we have Boolean expressions. We also have Boolean variables. And a Boolean variable contains either true or false. So in C# we'd write an expression such as bool, that's our data type, our Boolean data type, is living equals true. Maybe this is a value we want to keep track of a person, whether maybe a celebrity, whether they're still alive or have passed away. And the thing about Boolean expressions, where you're going to use these is in conditional structures, or maybe in a repetitional structure. So we're going to get into this in the next video lesson, but here's a general syntax for how these are used. We have an if statement, and inside parentheses is the Boolean expression, and then a set of curly braces. And those curly braces or curly brackets, if that expression is true, it will do whatever code is in this first set of curly brackets. And then we can have an else and another set of curly brackets, and if the expression is not true or it's false, it's going to do what's in this section of our Boolean block or Boolean structure, conditional structure. So I'm going to give you a couple minutes. I've got 6 different expressions here. What I'd like you to do is pause the video at this point and see if you can evaluate these expressions labeled A, B, C, D, E, or F for the variable x. Would x contain the value true, or would it contain the value false, given that A equals 2, B equals 3, and C equals 5? When you think you have those figured out, resume the video and you'll see the correct responses. Okay, so letter A, x equals 2 plus 2 is greater than 5, so 4 is greater than 5. Well, that's a false statement. Of course, 4 is not bigger than 5. Letter B, math.pow, 2 comma 3 would be 2 cubed, which would be 2 times 2 times 2, 4 times 2, or 8. And the expression is 8 equals 8. That, of course, is a true statement. Letter C, abc.length, and ABC being Microsoft, there are 9 characters in the word Microsoft, is less than 12. So 9 is less than or equal to 12. That, of course, is a true statement. ABC substring, OSO, is going to return the location of where that substring begins. And so OSO in Microsoft is going to begin at index 4, or the 5th character. And so that value would be a 4. And we're saying 4 does not equal minus 1. If we didn't find that expression, it would return a minus 1. So this is a way of testing to see if a phrase or a sentence or a paragraph or a document contains a particular set of letters. In this case, 4 does not equal 1. That's a true statement. And then we have the square root of 25 using math.sqrt. And by the way, that S should have been capitalized on sqrt. I apologize. That would be 5. 5 is the square root of 25. 5 is greater than 6. Nope, that is a false statement. And then A times B, 2 times 3 is 6, is less than or equal to 5. 6 is not less than or equal to 5, and that is a false statement. So one last thing is you can actually convert a Boolean value to an integer. And we can do that using convert.toInt32. So it's a 32-bit integer. And if it is false, the value of that integer conversion would be 0. So in this case, my variable I, which is declared as an integer, will contain a value of 0 if it's false. And if x is true, it would contain a value of 1. I'm hard-pressed to think of times when I've had to convert those to integers, but you might see that somewhere along the way. Just want to point that out. So that's our lesson on Boolean expressions. In the next lesson, we'll look at how to use them in an if conditional structure.